All right, here we go. We skip from chapter 8 to chapter 12. My guess is this is probably the our last chapter. All right, we'll see how it goes. If not, if we finish this early, maybe we'll go to another chapter. I've got another chapter in mind for us to hit. All right, but I wanted to make sure that you did not leave geometry without doing a little bit of trig. All right, and that's what we're doing today. It's just a little trig. See, look at this. That's a little trig right there. Thank you for your pity laugh. All right, I'll get rid of that dot. It's going to bug me if I keep that there. There we go. All right, so like I said just a second ago, trigonometric, big old fancy word, okay, basically means the study of angles, all right? And that's what, we've studied angles all year, but it's a little bit more, it's a little different, but it's also very similar, okay? What we're going to deal with until, let me see, I think there's a lesson where we get away. 12.3, areas, vectors, Let me see, identities. Okay, way up until section 6, 12.6. Is that the last one? Okay. So we're basically going to be dealing with right triangles, okay? Right triangles. We've already dealt with right triangles a lot, haven't we? Tell me some things about that we've done with right triangles. Pythagorean theorem. 30, 60, 90. What was the other one? 45, 45, 90. Okay, good. All right, so you know some things that we've already done with right triangles, and we're just going to do a little bit more. I thought for sure that I took notes on this, and I looked in my little folder with all my notes from geometry, and I can't find them, so I'm going to be looking at the book, which I don't usually do, but that's okay. I could probably teach this lesson without looking at anything, to tell you the truth. But I like to look at it so we can get an idea where to head here. All right, so I said it's talking about right triangles, so let's draw a right triangle. How about that? Yeah, let's do this first. Oh, what am I doing? There we go. All right, so here's a nice right triangle. Let's label some stuff on this right triangle before we do anything else. One of the words, well, actually, a couple of the words you've seen before, actually, all three of them. What do I call this side? This has a specific name on a right triangle. It's the hypotenuse, okay? How do I know it's the hypotenuse? How do I know that that's not the hypotenuse or that one's the hypotenuse? Very good. It's opposite the right angle. Everybody see that? So this is the hypotenuse because it's opposite the right angle. This right here is called one of our legs, right? And this right here is called one of our legs, all right? Everybody with me on this? Okay. So I'm going to get rid of those. So let's talk about this angle right here. Now, if I don't know the angle, I think we've already talked about this. What's a letter that we use? It's a Greek letter of the alphabet that we use to indicate an unknown angle. Theta, right. So we've seen that before, haven't we? It's right there. Thank you. All right, so we've seen that before. That's a theta. Kind of looks like the O in the Oriole thing if you're a baseball fan, but that's a Greek letter of the alphabet, and it's theta. We can use a lot of different letters. There's a lot of different letters in the Greek alphabet that we use in math. By the time I finished college, I was a math major. I was a straight math major in college, and I probably used half of the letters, at least half of the letters of the Greek alphabet by the time I finished my major in college. We use a lot of Greek letters, and a lot of them kind of have their own understood meaning. Okay, this letter usually stands for this. This Greek letter usually stands for that. So one of the most famous, I guess, Greek letters that we use, the first one that we usually use is theta to understand an unknown angle. We could have labeled this ABC, right? You could have PQR, XYZ, any letters that you wanted to use. And so you could have put an A here and said this is just angle A, correct? But a lot of times we use theta for an unknown angle, so we might as well just start doing it now, just to kind of get you used to it. At first it's kind of weird, but then after a while you're like, okay, it just means it's just a variable is all it is, okay? It just means we don't know what that is. It's theta. Everybody good? So if I deal with theta, remember, this is always going to be the hypotenuse. And we said that the hypotenuse was opposite the right angle, correct? Well, what side is opposite theta? Is it this one here, or is it this one down here? Okay, it's that one on the left over here. Okay, quickly, bring it up to me. I can't see it. When you do it, when you have the 2, well, the 2 divides into that 30, that 360, so that 2 will go away.
Change the top one or no?
No, it just turns into a 1. So you divided that by 2, it turns. No, you haven't done anything to that. Okay. The 2's already on the top, and it only changes the bottom. Okay. Because 2 goes into 2, 2 goes into 360, 180 times. Okay. All right, here we go. So this is the hypotenuse, and this side right here is what compared to this angle? It's opposite. So I'm going to write the word opposite. I'll just shorthand it though, okay? Put OPP. It used to be a song. It's probably too old for you. Seems like a new song for me. I don't even know the song. I just know the kids said it all the time. I think it means something bad. I used to say it all the time. Now they say OPP, you know what I mean, or something like that. You ever hear that song? Never? Nah, it was like in the 90s or something like that. Believe me, it was not a song I would normally listen to, but the kids always said it all the time. And then I was listening to a podcast the other day, and somebody said that, and the other person said, do you know what that means? They're like, no. And they told them. And like, oh, I've been saying that for all these years. I had no idea what it means. I guess it's something bad. I don't know. I don't even remember what they said it meant. Anyway, it just pops in my head. But anyway, this is opposite, okay? Hypotenuse, opposite. Now, here's a word. Don't think that we've used it this year. We may have. I'm not really sure, but we're going to use it now. This side right here, it's not opposite theta, is it? This is the opposite side. This side right here is next to this side. We have a word for next to. If I said, what is it? Say it. Adjacent. Have we used that word in here? Have we used that word yet? Can't remember if we did or not. So it's adjacent. All right. ADJ. Here, I'll spell it for you up here. Adjacent. Just means next to. All right. Have we used that before? We have used it? Okay. All right. I just can't remember. But anyway, so this is very important. Now, when I say this is opposite, it's opposite of what? Angle what? Angle theta. When I say adjacent, it's adjacent to what? Angle theta. All right, so it depends on which angle that you're dealing with. Make sense? All right. Now, the hypotenuse is always going to be the hypotenuse because it's opposite what? The right angle. Everybody got that? So it's very important that you know what angle that you're dealing with on which one's opposite, which one's adjacent. What if, I'm going to throw another Greek letter at you. You ready? We're going to call this alpha. And alpha kind of looks like that. All right? Everybody with me? All right, so it's an alpha. It's kind of like that. Make it a little bit bigger. All right. It's the you ever hear the verse in Revelation that Jesus says, I'm the Alpha and Omega, the beginning and the end. So guess what letter alpha represents as far as what coincides with the English alphabet? The A, right. It's the alpha. It's the beginning. It's the first letter of the alphabet, okay? So alpha and omega would be the last letter of the alphabet. All right, anyway, we're going to use alpha right here. So if I was dealing with angle alpha, what would this side be right here? Would this still be the adjacent side? This would be the opposite side, wouldn't it? So it all depends what angle you're dealing with, all right? And what would this side be right here? To angle alpha. This would be adjacent, right? So I'll put ADJ right there. All right, so it all depends which angle that you're working with, on which one is opposite, which one's adjacent. And hypotenuse is always going to be the hypotenuse, isn't it? Because it's only opposite the right angle, and that kind of stands on itself. Everybody good so far? Yeah, this is just the very beginning, but it's important to understand that. It's very important to understand because of what we're going to do a little bit later. Yes?
In the minus fractions, the denominators stay the same.
If the denominators are the same, you can multiply or subtract the fractions, yes.
It stays the same, which is the top number.
Right, the bottom stays the same, yes. Yeah. I don't know. We'll see how far we get. All right, I'm hoping to finish this section. All right, so what we're going to do now, what was the name of this lesson? It was trigonometric what? Ratios. What does that mean, a ratio? Something over something, okay? It's a comparison of two things. And a lot of times we compare two things, we make it a fraction, all right? So like 2 out of 10 kids do this, right? Or that, or whatever. You've seen that before. So those are ratios. Ratio is basically a fraction, all right? It's a comparison of one thing to another thing. So what we're going to do is we are going to compare sides of the triangle. I got 3 sides of the triangle. I'm going to make certain comparisons. I'm going to compare the opposite side to the adjacent side, the opposite side to the hypotenuse, the adjacent side to the hypotenuse, and so on. Everybody see that? So when we talk about these trig ratios, that's all it is. And I'm going to give you fancy words, okay, for what we call these ratios. But these are trig ratios. Here's your basic 3 trig ratios. I don't even know if they do the inverse ones or not. I don't think they do, at least not in this. So we'll just do 3 of them today, all right? There are 3 more, but we'll just do 3 today. So let's draw another triangle so we don't have all that mess. So I'll just make it look the same. Doesn't really matter. And it doesn't have to be anything special. It's not necessarily a 30, 60, 90 or 45, 45, 90 or anything like that. But it is a right triangle. So what we're doing only works with right triangles, okay? And let's do this. Let's call this A, B, and C. We'll go back to the theta eventually, but I think it'd be a good idea to call this A, B, and C. So if this is angle A, what do you think I'm going to make this side right here? You know what? Let me think about this for a sec. Yeah, I don't think we need the letters just yet. We'll do that later. Sorry about that. All right. And I think we will use this angle right here, theta. All right, so what I'm going to do is I'm going to make a comparison. Remember, this side right here is the opposite. I'll just put an O for opposite. Is that right? And this side right here is adjacent to theta, so I'll call that A for adjacent. This side right here is opposite the right angle, so that would be hypotenuse. What I'm going to do is 3 different ratios. I actually just read them off to you. What I'm going to do is I'm going to take this theta, I'm going to compare the opposite side to the hypotenuse. All right, and there are reasons why we want to make a comparison between 2 sides of a triangle. You won't really know right now why we're doing this, okay, but just trust me, we're going to use this later on, okay? We're going to need to compare the 2 sides of a triangle. So I'm going to make the opposite over the hypotenuse as one of my ratios, okay? Opposite over hypotenuse. Everybody got that? I'm going to give a name for it in a second, but I'm going to do the other 2 right now. Then I have another ratio that's going to compare the adjacent side to the hypotenuse. The adjacent side to the hypotenuse. Then I'm going to have another ratio that's going to compare the opposite side to the adjacent side. Okay? And so, again, it all depends on which side is opposite and adjacent depending what angle you're dealing with, okay? Because this could be the adjacent side if I was dealing with this angle up here. Do you see that? All right, so I'm dealing with this theta right here. So this would be opposite, this would be adjacent. Of course, this would always be hypotenuse. Yes? Yes, it does because of that comparison. Well, okay.
This one,
Yeah.
It's not an isosceles triangle, right?
It's not necessarily.
And then can I use the answer for this one from before?
Yeah, these all go together. Yep. Whatever you get for the one goes with the other ones. So what I do is I give this name, okay? So if this is opposite and hypotenuse, I give it a name, and the word that I use, tell you what, let's push this over just a tad. Give myself some room to write. Okay, what I'm going to use is the word sine, S-I-N-E, all right? but we abbreviate it. And what we abbreviate it to is just the first three letters, all right? And that's just SIN. But we don't say sin. What do we say? We say sine. This is just an abbreviation for it, okay? But we still say sine, all right? The sine of what? What angle am I using here? Theta, correct? So here's what we do. We say the sine of theta equals the opposite over the hypotenuse. What does the sine mean? It means that you always take the opposite side and compare it to the hypotenuse in that order. That's what you're asking, okay? So the sine is always the opposite side divided by the hypotenuse, okay? You with me? All right, that's all that word means. It just means, like, well, what does it mean? Is it a variable? No, it's not a variable. It's just a word that tells you to compare the opposite side to the hypotenuse. That's all that word means. Everybody got that? All right, so when you first look at it and you see all the SIN, and we're going to do cosine and then tangent in a second, when you see that at first, you're like, oh, I don't know what that means. All it means is you're comparing two sides of a right triangle. That's all it means. And it tells you which sides to compare. The sine, you just have to know that it compares the opposite side to the hypotenuse. You with me? The second one is the cosine. All right, cosine. And then we just use the first three letters again. Cosine, or COS, of theta equals the adjacent over hypotenuse. What does that mean? What does cosine mean? It means you're just comparing two sides of a triangle. Which two sides are you comparing? You're comparing the adjacent side to the hypotenuse. Does that make sense? You're not comparing the hypotenuse to the adjacent. It's got to be in that order. The adjacent's got to be on top. Hypotenuse has to be on bottom. Did you hear me? That's correct. Okay, you're just making a comparison. Adjacent over hypotenuse. And these could be numbers, right? You could have numbers here. Agreed? Because the length of the adjacent side has a certain number. The length of the hypotenuse has a certain number. All right. The third one is the tangent. So it's the tangent of theta. And it definitely makes a difference what your angle is, okay? If I'm dealing with this angle right here, the sine is this side, the opposite, over this side, the hypotenuse. Okay, if I was dealing with this angle up here, angle alpha, then this would be the opposite, and this would be the hypotenuse. Do you see how that would be different? Okay, so make sure you know what angle that you're dealing with. All right, so we use the tangent. I should have written the word down first. So tangent. We've used that word tangent, right? Just the last chapter, tangent of a circle and all that good stuff. But we shorten it to tan, T-A-N. All right, and that equals the opposite of adjacent. So you have to memorize these. These right here, memorize them. But I got a nice, cool little way that helps us memorize them. Look at the sine. The sine is the opposite over the hypotenuse, isn't it? The cosine is the adjacent over the hypotenuse. And the tangent is the opposite over the adjacent. So here's a little word. It's a mnemonic device. Have you ever heard that word? Mnemonic. Starts with an M, but it's silent. Mnemonic. Okay, so this is called a mnemonic device. Like, please excuse my dear Aunt Sally. That's a mnemonic device. You with me on that? So PEMDAS, right? That's a mnemonic device. Same thing here. So what I'm going to do is I'm going to make this SOH. I'm going to make this one, what do you think? CAH, and I'm going to make this one TOA. So this is how we say it. So-ka-toa. 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 Say that a bunch of times. Ready? So-ka-toa. 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 If you can remember, so-ka-toa, so-ka-toa doesn't mean anything, right? It's not real words, but it just lets us remember those letters. All right? So if you can remember this thing right here, you should be able to remember all of those, right? So-ka-toa. S-O-H, what does that mean? It means the sine equals the opposite over the hypotenuse. What does the ka mean? It means the cosine is the adjacent over the hypotenuse. What is the toa? It's the tangent equals the opposite over the adjacent. And it's very important that we know these ratios, okay? It's really going to help us. I promise you. And again, you might not see it right now, but You'll see it later. So what kind of question will they ask for this? Well, I'm glad you asked. This is what they're going to ask you to do. Everybody got that down right there? Okay. Yeah, you can go watch the video. Let's draw that same triangle again. Well, I'm going to draw it a little bit different. I'm just drawing it the way it looks in the book. So if you look in the book, it'll look the same. Still a right triangle. Again, these things only work with right triangles. Everybody hear me on this? All right. Almost the whole entire chapter is just about right triangles. So here's the deal. Let's call this angle A, call this B, call this C. Then I'm going to give you a couple values. I'm going to say that side right there is 5, and this side right here is 9. All right. Now, again, what we're going to do right now is just preparation for what we're going to do later. All right. So what we're doing right now, in and of itself, doesn't really help us. Doesn't really do much for us. But we will eventually get to a point where this is going to help us, and it's going to help you find this angle right here. And if I know this angle right here, I should be able to find that angle right there. We're not going to do that today, though. All right, we're not going to find that angle today, but pretty soon we will. I could do a little bit of math, a little bit of trig, and find exactly what that angle is equal to. And look, I don't even know that angle right there. All I know is that's a right angle. So just knowing two sides is going to allow us to find that angle right there. So that's kind of nice, isn't it? Yep. If I was building something, right, I had a right angle, I knew this side was this length, I knew that side right there was this length, I will be able to find both of these angles. And a lot of times that's very important to find, all right, depending on what you're doing, all right? So what I'm going to have you do, I don't think, yeah, they don't ask you to do this. I'm going to ask you to do it, though, okay? I'm going to write the 3 trig ratios for angle A, and then I'm going to write the 3 trig ratios for angle B. What do I mean, the 3 trig ratios? What are they? Sine, cosine, and tangent, okay? All right, so angle A. Now, I'm not using theta in this one, okay? I'm just using these regular letters, all right? So this is the angle that I'm going to deal with right there. So what is the 5 to this angle? It's opposite. What's this 9 right here to this angle? It's, no? What's the 9? It's hypotenuse because it's opposite the right angle, okay? What's one thing we don't know? Yeah, you don't know the adjacent. Can you find the adjacent without doing any trig at all? Yeah, something we did a couple chapters ago, right? Pythagorean theorem. So let's find it, all right? I'm not even going to put let's just put an x right there. So let's solve for x. Can we do that first? Let's do that before we find our trig ratios. So what would that be? It'd be x squared plus what? 5 squared equals 9 squared. Yeah, you might have been able to get 25 and written that down right off the top of your head, but I want to show you all the steps. That equals 81. You subtract 25 from both sides. What's that, 56? Is that right? Did I do the math right? So x is equal to 56. Not 56, but what? Because this is x squared, sorry. This is x squared. So what's x equal to? Square root of what? 56. Can we simplify that? Yeah, so watch. What's equal to 56? What's the first thing that comes to mind when you think of 56? 3? No, 3 doesn't go into that. 9 and 6? What's 9 times 6? That's 54. It's not 56. 8 times 7. Thank you. Okay, now watch this. I'm going to do a little bit in my head. I'm not here to teach you how to simplify fractions, but we need, or radicals or square roots. But let's do it. It's 8 times what? 7. Let's break down 8 a little bit more. Let's break down 8. What times what is 8? 4 times 2, correct? And then times 7. Would you agree that that's still 56? Let's do a little of this in our head. What's the square root of 4? It's just a 2. Can I take the square root of either one of these things? No. So This is 2 times the square root of 14. All right? So that's what I'm going to write this as, 2 times the square root of 14. So that's the first thing I had to do. Everybody okay with that? So now, once I find all 3 sides, now I can do all 3 trig ratios. So let's do them. What's the sine? Now watch, this is angle A, so all I do is put a capital A next to it. Instead of the theta like we did earlier, this is angle A, so I just put in A, all right? And then we're going to find the cosine of B. I'm sorry, I lied. The cosine of A again, and then I was thinking what we're going to do next. And then the tangent of A. So let's do it. And you're going to see some similarities between this and this once we do it. The sine of A. So here's angle A right there. So what is it? It's so katoa. So what is so? Without looking at your notes. Sine, which is opposite over hypotenuse. And that's how you use that little mnemonic device, okay? So you think so katoa. After a while, after you do these so many times, you probably won't even have to go to that. You just automatically probably know that the sine is opposite over hypotenuse. But you don't now because you just learned it, okay? So opposite over hypotenuse. Again, we're using this angle right here. What is opposite angle A? 5. Over the hypotenuse. What's the hypotenuse? 9. Everybody with me? Okay. Let's do the cosine. What's the cosine? Cos, C-A-H. You got it. Adjacent over hypotenuse. So which side is adjacent to angle A? Which is 2 square root of 14. So it's 2 square root of 14 over the hypotenuse. What's the hypotenuse? 9. So that would be the cosine of that angle. Why do we care? We're going to learn later why we care. All right? There is a reason. I promise. There is a reason why we're doing these things, and we're going to actually solve for stuff. We're going to use this information right here to be able to solve for angle A. Just not today. All right? The tangent of A. Tangent, TOA, T-O-A. Opposite over adjacent. So again, start with A. What's the opposite? 5 over the adjacent, which is 2 square root of 14. Now we got to simplify this. It's kind of ugly, but watch. Remember how to simplify a square root on the bottom? Remember you can't have a square root on the bottom? So what do? We multiply the top and bottom by the square root of 14. Square root of 14. So what do we get? We get 5 times the square root of 14 over what? Well, square root of 14 times square root of 14 is 14 times 2, which is 28. So the tangent of A, I'll tell you what, let's write it right here. So the tangent of A is equal to that crazy number. 5 square root of 14 over 28. That's ugly, I know, but that's what it is. Say that again, a little louder. Yeah, when you have a square root on the bottom, that's the only time you have to do this thing right here, okay? But after you do it a few times, it's almost second nature. You see it, you're like, oh, okay. Multiply by the square root on the top, square root on the bottom. It works out. The math is easy, isn't it? Just put 5 square root of 14 right here. All you had to do, square root of 14 times square root of 14 is 14 times this 2, which is 28. All right? So those are my 3 trig ratios for angle A. Okay? Now what do we have to do? Do the same thing, but what are we going to do it with? Angle B. Yes. No, only on the bottom. Okay? You're allowed to have square roots on top all day long. No big deal. You just can't have a square root on the bottom. All right, check this out. Let's do the same thing, but we're doing it for angle B this time. So this is going to be the sine of B. This is going to be cosine of B. And this is going to be tangent of B. So things change a little bit now, okay? Because now we're dealing with this other angle. You got it? So let's do the sine. Let's go through it again. What is the sine? It's SOH, S-O-H. What is that? Opposite over hypotenuse. But I'm doing angle B this time. So what's opposite angle B? Two square root of 14. Right. 2 square root of 14. That's the opposite over the hypotenuse. What's the hypotenuse? It's 9. Does that look familiar over here? Yeah, check this out. The sine of b is the same thing as what? The cosine of a. All right, that's pretty important to see. So what do you think? Without even looking at this, just look at the stuff that we wrote down and see what we just did. What do you think the cosine of b is equal to? The same thing as the what? The sine of a. That's right. The cosine of b is going to be the same thing as the sine of a. Let's see if it really is. So again, here's b. We're going adjacent over hypotenuse this time. Adjacent is 5. Hypotenuse is 9. So what is it? It's 5 over 9. Guys with me? Okay. That's kind of interesting, don't you think? That you get the same thing for the sine of b as you do the cosine of a. Yep, and the same thing for the sine of a and the cosine of b. What about b, tangent of b? Again, what's tangent? TOA, T-O-A. So it's opposite over adjacent. So which one is opposite b? 2 squared of 14 over the adjacent, which is 5. Isn't that just the opposite of what this was? Everybody see that? It's just an inverse, right? It's just reciprocal of this. Do we have to do that whole thing that we did with the square root of 14 on this one? No, why not? Because it's on the top. It's not on the bottom, right? And there you go. So there's your trig ratios for the other angle. What we just did right there is super, super important. It's stuff that we're going to use a lot. We're going to go a little bit further than this. We're not just going to write the ratios. We're going to use this, and we're going to use a calculator to figure out what these two angles are, A and B, from this information. And we don't have to do like all 6 of them. All we got to do is just one of them, and I could solve for A. All right? But I wanted to do all of them just so you can kind of see your options. You with me on that? Okay. Let's do another. All right, this one, they kind of changed the wording of it a little bit. So let's see if you really understood what we've been talking about. So far, it hasn't been bad, has it? No, you just have to know what the sine, cosine, and tangent mean. You got to know what the ratios are, right? Opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. If you know those, then actually doing these things really isn't all that bad. I'm not saying it's easy, but it's just not as bad as what it looks, okay? It looks terrifying when you first see it, right? Because you don't know what any of that stuff means. Obviously, it's going to look tough. But once you unravel a little bit, it works out pretty good. All right, it says given. Now look, they don't tell you any sides yet, do they? But here's what they give you. They give it to you in a little different form. They say that the cosine of A, I got to put the letters in here though. That would help. A, B, that's a B, and C. All right. So they say given that the cosine of angle A is equal to 3/5. They tell you that. No way you could figure that out by looking at it. They tell you. That's why it's given. Everybody with me? All right, so they tell you this. Then they ask you to find the sine of A and also the tangent of A. How in the world can we find sine of A and tangent of A if I don't know which one's opposite, which one's adjacent, which one's hypotenuse? But they give you a big hint though, don't they? Here's the hint. What is the cosine? What's the opposite, hypotenuse, adjacent, all that stuff? What's that? What's the cosine? Sound it out. What is it? Is it opposite for cosine? It's adjacent and hypotenuse. The ca, C-A-H, right? You got a so, you got a ka, you got a toa, right? So, ka, toa. So the ka, C-A-H, is adjacent over hypotenuse. So check this out. Which one do you think is adjacent? The C. That would be adjacent. Which one do you think is the hypotenuse? Oops. The 5 is the hypotenuse. So what are we going to mark on our picture? If this is angle A, let's do the hypotenuse first. That's the easiest one. That would be right there, wouldn't it? Okay. Which one is adjacent to this angle right here? AC is. And so I'm going to call that what? 3. Now check this out. Here's something nice. And this is one time we can actually use it. I need to find, if I'm going to find the sine and tangent, I'm going to have to find this over here, aren't I? Because this would be opposite of A. So I need the opposite for both of these things, right? Opposite over hypotenuse, opposite over adjacent. So I need the opposite. Without doing any math at all, what is the opposite? It's 4, right? Because it's a what kind of triangle? 3, 4, 5. Wasn't that nice? That's where we can use the Pythagorean triple. If you didn't remember that, what could you do? Pythagorean theorem, then solve for that. Make sense? But they made it real nice and easy for you. And now we don't have to worry about any square roots. That's nice. So let's see what we get. What is the sine of A then? So now we know all the sides. Now I should be able to find the sine. That's the easy part. What is the sine of this angle? It's what over what? Opposite over hypotenuse. Okay, so which one's opposite of angle A? 4. What's the hypotenuse? 5. There you go. What's the tangent of A? Tangent is opposite over adjacent, right? So what is opposite angle A? 4 is. That's the opposite over the adjacent. What's the adjacent? The adjacent? Adjacent is 3. 5 is the hypotenuse. The adjacent is 3. And that's what they want. Okay, that's one of your answers. That's your other answer right there. And again, I'll say this again. I'm repeating myself, but that's okay. That in and of itself, just knowing that the ratio is 4 over 5 doesn't really do much for us. But we are going to use those numbers. We're going to use those things and a calculator later on. I don't know what lesson. I can't remember. But we're going to use that stuff in order to actually find the degree measure of angle A. I'm actually going to find angle A with this information. We could have never done that before, could we? If I didn't know either one of these angles, there's no way I could have done it. Now, if I knew one of the angles, I could always find the other one up here just by taking it away from 90. Remember that? But if I don't know either one of them, I couldn't do this without trig. It would be impossible. Yes? If it came out to where you needed to reduce, yes, you would. But neither one of these do reduce. Okay? And 4/3, making it 1 1/3 is not reducing it. Okay? So just keep it 4 over 3. That's the best way to do it. Good question. Okay, let's see what else we got. A couple more things. All right. You know what? I think I will make this a and B because I really want to spend some time on the next thing. And I could do it very quickly and just show you some stuff, but let me show you how to do stuff in a calculator. All right. Yeah, I mean, look, you can do this in a calculator, right? 4 over 5. You can put that in there. What is that? It's 8 over 10, 0.8, right? So if I put it into a calculator, then the sine of A is equal to what? Point what? 0.8. A lot of times we take it to 4 decimal places, so I'll put some zeros there, okay? 4/3 is 1 1/3, isn't it? So the tangent of A would be 1 1/3. How do I write 1/3 as a decimal? You should know that off the top of your head. It's just 3 repeating. And we're going to go how many decimal places? 4 decimal places, okay? Now, if you wanted to put this right here into a calculator, that's a little bit rougher, okay? So I'll show you. We got 5 minutes. You got your calculator out? Pull the calculator out, okay? And I'll show you how to do it. If you have like a regular scientific calculator, I'm going to show you how to do that. Yep. Well, yours could possibly be different. I'm going to show you 2 ways to do it, okay? So you need to know how your calculator works. You have a graphing calculator, Noah? Okay, so I'm going to show you how to do it on a graphing calculator. I do not have a little scientific calculator that pops up on the, well, I don't know, maybe. Let's see, does Desmos have a calculator? I think it does. Okay, oops. Let me click on this so that Desmos pops up. I'm just winging it here. I'm pretty sure it does this. Yeah, it does. Okay. So everybody watch. I just want to see something. Do I hit square root first, and then hit 9, and hit equals? Yeah. So on this one, listen, hey. I'm still teaching. So, yeah, this works just like this is called direct algebraic logic. So if I hit the square root of a number, you'd hit the square root first, okay? Remember we had that, what did we have? I flipped the page. Let me see, what did we have? Square root of 14 over something or other. What was that? 2 square root of 14. So watch. This is how you would do it if you had a graphing calculator, all right? So you go 2, oops, lost my stuff. Okay, square root of 14, and then what was that? Over what? Okay, do you see how it gives you a decimal right there already? And then, actually, I don't know if you have to put parentheses or not. I'm going to, just to be careful. Okay, 2 squared of 14 over 9, is that what it was? All right, over 9, there you go. See that? And that would be your decimal answer right there, 0.831. We wouldn't keep it a 4, though, would we? Why not? Because that 7 does what to that 4? Makes it to a 5. So if I asked you to round it to 4 decimal places, which a lot of times they do, all right, then it would be 0.8315. That's what you would do there. Yeah, that's 4 decimal places. If you just put 0.8, if you just point 0.8, then you're only taking it to 1 decimal place. The zeros tell you something, okay? The zeros say that means there's not a 1 right next to it, there's not a 3, there's not a 4 right next to it, right? So the zeros definitely tell you stuff. So that's how you would do it on your calculator. Now, if you have a scientific calculator, here, let's go back to this. Let me change it on here. There we go. If you just had a regular scientific calculator, you would not hit the square root first. Okay, so what was that again? 2 square root of 14 over 9? Was that what it was? Okay. If you have a regular scientific calculator, this is what you would do. You would hit 2. I'm going to put it in a square. Okay, 2. And then you would hit 14. You'd hit 2 numbers, 1 and 4, but I'll put 14 in one box, okay? I'm sorry, you'd hit times. Okay? And then you would hit a square root button. What that's going to do, let me just make sure that's right. Try it on my scientific calculator on my phone. So 2 times 14, square root equals, So you hit 2 times 14, then you hit the square root. I don't know why I put square root of 2. Why did I put a 2 there? Just a square root. Everybody see that? And then once you hit equals, it'll give you a number, 7.4833, blah, blah, blah. Okay? And then, after you hit equals, then what you would do is hit divide, and then you would hit 9. And then you hit equals again. I don't think you really need the equals right there, but I would probably do that just to make sure. All right, so you take that, divide it by 9, and that's that number I gave before, 0.83147, but that 7 rounds the 4 to a 5, so that's how I'd write that answer. Make sure, it's very, very important. Everybody hear me? Everybody's listening, paying attention, not packing up, right? Everybody's listening to me. It's very, very important, especially a little bit later, that you know how to use your calculator. If you're going to do something like this, you must understand how to put it in your calculator. There's 2 ways to do it. The way that I showed you earlier, if you have a graphing calculator, even some of the ones that just look like a scientific calculator, Now, some of them, depending on what type it is, will have you do it the other way that I did. All right? That's called direct algebraic logic, which means if it says the square root of something, you hit square root first, then the number. The, quote, normal way, I guess. So is that how yours works?
Yeah, mine works
the square root. You hit square root first. Yours? Okay. Right. But so if I had the square root of 16, watch, some calculators, you actually hit square root first, and then you hit 16. Other calculators, what do you hit first? You hit 16 first, then you hit the square root button. All right? They're both going to give you the same answer, but you have to know which way your calculator works. Okay? All right, yep. So make sure that you know that, all right? I am going to, don't run off yet. Don't be too quick and hasty. I don't have, oh yeah, I do. Is it 1 through 18? Let me just double check. Just do 1 through 12, all right? You won't be able to do the other ones. We're going to have to hit that the next day, all right? So let's just do 1 through 12. You should be able to do all of those, I believe. Yes, you should be able to, okay? 1 through 12, section 12.1. 12.1, 1 to 12.